Okay, so up to this point, well, let me take roll quick. Okay, so we've learned two different types of chemistries up to this point. Okay, so one of them is the beginning of biochemistry, the other one is organic chemistry. According to evaluation yesterday, which do you think came first, the organic chemistry or the biochemistry?
Organic chemistry.
Why is organic correct? Organic compounds like methane all the way up to decane. Okay? So without any further context, what can you tell me? What is in between methane and decane? Starting with methane, what's next? Ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Now, in a fractionating tower, some of you were absent because, yes, you were at a track meet, and some of you who were here, in that fractionating tower where distillation takes place, we've talked about a significance between propane and butane. So what might some of the physical characteristics be different between propane and butane? The example we gave, if you put the two together, a propane grill and how you light it if you don't have a striker, sparker, where you hit the button, it puts a spark, and then whoosh, something like that. So what would the difference be between propane and butane? One's in a gaseous state. Which one? Okay, then what does that tell you about butane then? Butane is a liquid. So in that fractionating tower, carbons 1, 2, and 3 go through a distillation process because they will change to a gas and then liquefy and then condense back to a gas again. Okay? But butane on down, okay, those are all liquids then. And when you get to those heavier hydrocarbons, hydrogen and just carbon, okay, you have octane on top. No, that's not right.
No.
Kerosene on top. Then what would come after kerosene? We just said it. No. Then you have octane, which is known as what? Gasoline. Then underneath gasoline, you'd have these types of oils, lubricating oils. And then the heaviest of all hydrocarbons, asphalt, tar. Right, that's correct. In somewhere around the 20 carbon range. All right. So, what are some other divisions of organic chemistry? Because what we meant is we just did alkanes. What is the simplest? What's the next step up in complexity? Alkenes. So if something ends in E and E, what does that tell you? There's a double bond somewhere. And if something ends in Y and E, that means there's a triple bond. Okay, we just a lot of material in a short amount of time. Is anyone confused with that? Front row. We're good? Okay. Front row. Okay. Second row. Okay. Third row. Okay, so everyone's nodding their head yes or giving a thumbs up. So what are you telling us as staff members? That you understand this. Okay, so you understand this. All right. And if you don't, there's nothing wrong with that. You can always come in and ask for help. Okay? But whose responsibility is that? It's your responsibility. Right. Okay. So if the suffix ends in Oh, I see.
Acid.
Right. How did you know that?
Because we learned it.
Yeah.
I see.
Oh, I see it. Yeah.
Sir.
Oh, I see. Yeah. Okay. Of course, this is not what we're talking about. This is part of what we're talking about vitamins in the biochemistry class. Well, how does the body break those down? Well, that's something that you learn if you stick around long enough in chemistry. Okay. Okay, this could be a common mistake. If we told you to draw this, why is that wrong? Okay, now just don't say blah, 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 blah. Look at that right carbon and tell me what's wrong with that. Because what column is carbon in? So that means it can only have how many bonds? It can only have 4. So there's 1, 2, 3, 4. That makes 5. It can't do that. Okay? So, what would be the first thing that you would do looking and naming that compound, just like what we've been doing the last 3 weeks? Your longest parent chain, which is how many?
2.
So what is your prefix for 2 carbons? Okay? Okay? We don't want to do that. No. Why not? Because what are you saying? Okay, this is perhaps some of the issues that you may come across. We're trying to explain this to you individuals, and then we don't know what we're doing. Okay? So why can't we do this? It's not an alcohol. Okay? Now it is. Okay? Now that would be correct, but that's not what we have. Okay. So then we already said what is your suffix for this. Okay? Okay? Sometimes we refer to common name for compounds. Okay? So what that means is we've made reference to that. We could call this ethyne. This means we've got a triple bond. That means we've got 2 carbons. But I guarantee you no one's going to know what you're talking about when you say ethyne. Well, they might. Because if you have a cutting torch, you would say acetylene. You wouldn't say ethyne. You would say acetylene. So sometimes common names are used. So in this case, it's often referred to as this, acetic acid, or actually this, vinegar. Vinegar is just acetic acid, which is just ethanoic acid. So sometimes common names can be well. But for our purposes, we would say ethanoic acid. Okay? Okay. Then, what do these names in blue mean? We spent the last few days working on those. Those are what? Those are not benzene structure. Oh, didn't I say blue? Yeah, in the blue. Those are amino acids. Okay. Could we draw amino acids? Okay. Would that be, who would be confident, I would perceive that, could everybody come up here and draw if I picked someone? Who would say, please do not pick me? Okay. So then, if we're here to help you and we're saying, okay, we don't get it, why do we keep chatting when we're going through this? Not everybody. Okay. It's just a question. Okay. Kind of like if you're old enough to remember, sometimes you have to ask Mr. Owl there, how many licks of the Tootsie Pop does it take to get to the center? The world may never know, just like we may never know why we talk when we're going over this. I don't know. Okay. The reason that these have asterisks is because these are the ones that you're responsible for. Okay? The juniors have 3 or 4 more upon what you're doing. Then the seniors have about 8 more than what you're asked to know. That's why we take this in what we like to think is a nice, slow progression. Okay, do these amino acid structures have anything in common? Okay, so let's just look at this term. We probably have done this 3 or 4 times. I don't know. Amino acids. Okay? So if they have something in common, what is an amino group? Okay, nitrogen's part of it. There's our hydrogens. I just do this by habit. Okay? Okay, carbon.
One more carbon. And then double bond and oxygen. And then alcohol.
Okay. We have an amino side, and here's our acid side. That carbon isn't quite complete yet. Okay, we need to have 2 more dashes. Is that a completed amino acid? Yes, it is. Which amino acid would that be? Top one, glycine. Okay? So if we were going to have you draw alanine, do we need to erase all this and start over? No, we don't. Okay? Little more context, though. Okay, 3 more hydrogens. Now we've got the amino acid alanine. Okay? Then if we want to draw valine, do we need to erase all of this again? No. Do we see a pattern? Where do these amino acids change? In the middle, right on this second carbon. So, how could we change alanine to valine now? Okay, make like a V. I'm going to extend this out a little bit. Okay. So this is what we're interpreting you're saying by a V. So it's actually called an isopropyl group. But why would this help you in naming your amino acids? Yeah, because it looks like an inverted V. So that's how we know that it's valine. Okay. Then the good one. Everyone likes this analogy, I bet. A little useless trivia for you. Okay? The largest church in the world is located in the smallest country in the world. Okay? So what's the largest church/religion? Christianity. Catholics. So if that's the largest church, which it is, what's the smallest country in the world? Where does the Pope reside? Vatican City. Vatican City is actually its own country. Oh, well, yeah, they could try, but I don't think it'd work very well.
Why?
Because why would you declare it? I guess I don't know. Okay, I'm not going to try to make anything up. You asked me a valid question, so I'm going to say, I guess I really don't know. how would the country support itself? I don't know. I mean, TNR can only go so far. Okay. All right. So, okay, getting back on track here. What's the name of the dome slash chapel that not Donatello. Well, yeah, it sounds like Ninja Turtles, but I can't remember. Leonardo did. Michelangelo. Michelangelo painted the Sistine Chapel. Okay? So then, what's the name of that amino acid? I pronounce it cysteine, and there's a reason for that. Okay? Because if you are a tour group going through and visiting the Sistine Chapel, it would probably be a life-changing event to see that beautiful artwork. But as you're walking through there, you see people talking and being inappropriate, you would say,
Stop that.
right, maybe that too. You go, shh, this is the Sistine Chapel. Okay? So that means, how do you spell? The simplest way to spell shh is what? Yeah. So S and H. And if you want to put that on here, you can. But remember, if there's nothing written after these dashes, it just means a hydrogen. So yeah, that's the Sistine Chapel. Okay. All right. What is everything you know about photosynthesis, or our best energy source is what? It starts with a G. Glucose. That's right. Okay? So glucose has this formula, C6H12O6. Okay? And if we were talking about any type of animal or human, you could say that we actually burn this, right? For fuel. I mean, you don't need to write this part down because don't we need oxygen? Okay? So then upon burning this fuel, known as glucose, with oxygen, what do we give off as byproducts? CO2 and H2O. That's right. But this molecule has to be broken down. I just stepped on my charger here. Just a moment. Good one, I know. That's why it was such a good apple wheat. Okay. So now when we look at this, okay, why would something like this be significant? If that's all the further we had, what side of a figure could you presume that that is? Which is a hexagon. Okay. So this I would recommend that you write down.
Are we just supposed to write the C6H12?
Okay. I'll give you a couple of moments to catch up with that.
I'm lost in the zone. It's okay. Dude, I'll cross it.
See how great of artistes You are. Maybe they'll put you to work in the Vatican City touching up the Sistine Chapel. Yes, this is, you referring to that? That is an oxygen atom. That's correct. Okay. Is it possible that these two, this molecular formula matches up with that structural formula? So, do you think it is the same thing upon first observance? Okay, so keep in mind if you're drawing even cyclohexane, okay, even if you're drawing that, okay, we know that it's a six-sided figure, right? And every intersection of these lines is accounting for which atom? Exactly. So each intersection, whether it's here or here, is going to be a carbon atom. So when we look at this, here's 1, 2, 3, 4, 5, and then up top here is number 6. So there's our 6 carbons. Okay? So we need 12 hydrogens. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 2 more, gives you 12. Okay? Then for oxygens, that's why it was so important to observe that, whoever had asked that, that yes, that is an oxygen atom. Because there gives us 1, 2, 3, 4, 5, 6. There is your 6 oxygens. Okay? The reason that you're writing this down, you don't have to go through the same process that your juniors do. You certainly don't have to go through the same process that the seniors do. Okay? Because we will have these as matching questions. Because this could be something else that you could see. Don't write this down. Notice that those are almost identical. But what is the difference? Kind of like a little seek and find. What's the difference between the one on the left and the one on the right?
Basically,
One's at a higher level than the other. Like one the seniors do and the other one
Well, yeah, you could say that too. But structurally, how are they different?
about
There's only one spot that it differs.
at the bottom. There's no
Can you be a little more specific? But which one?
the right one on the right side.
Okay, so right side.
No, right bottom.
Right here?
Yes, sir.
Yes. Because this, remember, is called glucose. This is actually called mannose. No. Mayonnaise is a colloid. Okay. So if you hook these two together, which you could, that's where you get the disaccharide maltose. Okay? Because has anyone ever heard of fructose?
Yeah.
Because anyone, you look at a Gatorade bottle, pop can, whichever, the ingredients will say carbonated water and then blank type of sweetener. high. Anyone? It's something that just maybe never paid attention to. Okay, so we could look at this. Okay, the ingredients. Okay, I just got to look at where it's at. Carbonated water, high fructose corn syrup. Okay, so every soft drink, pop, soda, whichever, high fructose corn syrup. That is a type of sugar. Okay. I believe that is enough for today. We're going to watch about sugars and some of its significance. So next week, okay, we are going to review sugars again. Then we're reviewing chapter 23 on Tuesday. Some of you are gone to a track meet, I believe, April 30. Oh, nope, that's not till 1 o'clock, okay? Do freshmen miss any more morning classes because of track? Besides the conference meet? You don't know. Any reschedules that were postponed that you're aware?
We don't. They were postponed, but we don't know when.
Okay, you don't know when? Okay, asked and answered. Okay. So, we're going to take 2 days of review.
Mr. Hemmer to his office, please. Mr. Hemmer.
Okay, so 2 days of review, Tuesday, Wednesday, two-part exam. Okay, lots of time to review, lots of time to ask questions if you have them. Okay, we'll catch up to you next time.